Imagine falling into an ocean with no shoreline, no bottom you can see, and no place to hide. Then something appears below you, not a shark, not exactly. Its body is torpedo smooth. Its head barely breaks the water around it. Its tail is built like a living engine. Everything about it says the same thing: speed, pursuit, impact. It looks familiar enough to name in a second. And that is the problem. Because if you were dropped into Earth's oceans at different points in time, the animal rising towards you might be a fish, or a reptile, or a mammal. It might come from bloodlines separated by tens of millions of years. It might belong to a branch of life that had no right to look like the others. And yet, again and again, evolution produces the same silhouette, the same hunter, the same hydrodynamic weapon, the same predator. So here's the mystery. If evolution is supposed to be chaotic, messy, and wildly creative, why does it keep building the same killer? Natural History Museum, Smithsonian. Most people think evolution works like a giant randomizer. Throw enough time at life, and anything can happen. 1,000 strange experiments. Endless weird forms. Total unpredictability. And to a point, that's true. But out in the open ocean, something unsettling happens to that idea. Very different animals begin arriving at very similar answers. Sharks did it, dolphins did it, Ichthyosaurs did it. Later, other marine hunters pushed in the same direction too. At first glance, that sounds almost comforting. Nature finds what works. But look closer, and it becomes strange. Because these animals were not close relatives borrowing the same blueprint from some shared marine ancestor. The Natural History Museum describes convergent evolution as a process in which organisms that are not closely related independently evolve similar features as solutions to similar problems. In other words, these predators did not inherit the same design. They arrived there separately. That means evolution did not create one masterpiece and pass it down. It kept reinventing it. And that raises a darker possibility. Maybe the open ocean doesn't allow unlimited forms. Maybe it pressures life into a narrow corridor. Maybe when the hunt happens in blue water and the prey is fast, nature starts closing doors, until only one body plan keeps surviving. This is where people usually make a simple assumption. They assume the same predator is just a visual coincidence. A shark looks a bit like a dolphin. A dolphin looks a bit like an ichthyosaur. Same environment, same general shape, end of story. But that's not what happened. Scientists studying repeated marine evolution found that the similarity goes beyond a vague outline. Smithsonian researchers described dolphins and ichthyosaurs as descending from distinct terrestrial species, yet independently converging on an extremely similar fish-like body plan, even though they were separated in time by more than 50 million years. They also note that land-to-sea transitions happen dozens of times among reptiles, mammals, and birds. Smithsonian dozens of attempts. Different starting points, and still, familiar results. That is no longer coincidence. That is a pattern. And patterns in evolution are dangerous because they suggest constraint. Think about what water does. On land, animals can be bulky, spindly, towering, armored, crouched, flat, spring-loaded, or bizarrely asymmetrical. Gravity matters. Terrain matters. Hiding matters. Climbing matters. But water is a different judge. Water punishes drag. Water punishes wasted motion. Water punishes hesitation. If you want to chase prey in the open sea, your body cannot just be alive. It has to become efficient. That is why scientists use a more precise term for one of these repeated designs: the thunniform body plan. A 2023 paper describes it as a fusiform, spindle-shaped body with a compressed tailbase, stabilizing keels, a crescent-shaped tail fin, and an extra joint near the tail that helps improve propulsive efficiency. It is not merely streamlined. It is specialized for cruising fast while reducing drag and maximizing thrust. Now the mystery gets sharper. Because the animals that converged on this design were not just similar-looking swimmers. The paper identifies tunas, Lamnid sharks, modern whales, and derived ichthyosaurs as separate groups that converged on the same high-efficiency plan: fish, cartilaginous fish, mammals, reptiles, different ancestries. Same answer. It is almost like watching different inventors, in different centuries, on different continents, all sketch the same fighter jet. And if that sounds impressive, here's where it becomes unsettling. Some of these lineages were not born in the ocean, they returned to it. That means a land animal with walking limbs, weight-bearing skeleton, And a body built for air had to be remodeled into something that could cut through water like a launched spear. Smithsonian notes that legs adapted for walking were repeatedly transformed into fins, from seals to mosasaurs, allowing fast and efficient movement in water. Smithsonian imagined taking a wolf, a lizard, a giant rat, and a bird, then asking all of them to solve the same engineering problem, become an ocean-pursued predator. You would expect a gallery of weird failures. Instead, evolution keeps narrowing them toward the same silhouette, and the fossil record suggests it can happen disturbingly fast. A POS-1 study on the Mosasaur platycarpus found that a streamlined body plan and crescent-shaped tail fin were already established earlier than expected. The authors argued that advanced aquatic adaptations in Mosasaur's flipper-shaped limbs, a streamlined body, and a distinct tail fin functioning as an oscillating foil likely originated within less than 10 million years after divergence from their terrestrial sister group. Less than 10 million years. In evolutionary terms, that is not leisurely experimentation. That is a rapid pivot toward a proven machine. And Platycarpus was not alone. That same study notes comparable patterns in Ichthyosaurs and metrioranchid crocodiliforms. Different reptile branches, different histories. Yet they all accelerated towards streamlined marine forms early in their oceanic lives. So now the mystery is bigger than one predator. It is about whether certain environments force evolution into repeating itself. Because the open ocean is not just a habitat. It is a filter, and it filters brutally. To a human body, water feels soft. Float in it, and it seems forgiving. But to a hunter trying to overtake fast prey, water is more like heavy air made of consequences. Every extra wobble steals speed. Every broad surface creates resistance. If a human tried to catch a tuna in open water, the result would be comic. If a whale with the wrong body plan tried, it would starve. If a reptile returned to the sea and failed to streamline quickly enough, it would become a lesson in extinction. That helps explain why the repeated predator keeps appearing. Nature is not obsessively copying a monster because it loves the shape. It is doing it because prey moved the goalposts. The 2023 study argues that thunniform swimming appears linked to the evolution of prey types and niche availability through geologic time. These predators mainly fed on fast pelagic prey such as cephalopods and teleos fishes, and those prey groups diversified strongly from the Jurassic onward. In simple terms, when prey got faster in the open ocean, predators had to become faster too. Evolution was not sculpting an icon. It was responding to an arms race. Once the ocean filled with quick, evasive prey, the old body plan stopped being enough. Bulk became expensive. Drag became fatal. A predator could no longer just be strong. It had to be efficient over distance, stable at speed, and capable of turning muscle into thrust with frightening economy. That is why the same solution keeps emerging. Not because nature lacks imagination. Because under those conditions, imagination gets outvoted by physics. And still, the story becomes stranger. Because sometimes evolution doesn't just repeat a design while one version already exists. Sometimes it repeats the design after a previous dynasty disappears. The same 2023 paper suggests that the extinction of Ichthyosaurs likely opened a thunniform niche that could later be filled by lamniform sharks possessing at least part of that toolkit. Think about what that means. A predator vanishes. It requests it again. That is one of the coldest things evolution ever tells us. The individual lineage may be disposable, but the ecological job remains. The hunter role survives the hunter. And once that role exists, evolution keeps drafting new bodies to perform it. This is the point where the mystery turns from biological to almost existential, because we like to think life is a tree of endless branches. But out in the sea, it starts looking less like a tree and more like a maze with hidden walls. Different creatures run through different corridors, only to crash into the same final room. A spindle-shaped body, a powerful tail. A reduced set of wasted features. A predator optimized for pursuit. And yet the repetition is not perfect. Smithsonian points out that not all marine adaptations can be explained by convergence alone. Baleen whales evolved a unique filter-feeding system. Toothed whales evolved echolocation for hunting. In deep divers like beaked whales and seals, mussels independently evolved positively charged myoglobin to support long submergence. Smithsonian, so evolution is not photocopying one animal. It is doing something more interesting. It repeats what physics demands and improvises where opportunity remains. That may be the biggest reveal in this entire mystery. The same predator is not one species. It is one recurring compromise. A body fast enough to own open water, flexible enough to emerge from different ancestries, efficient enough that nature keeps rediscovering it. And there is still one unresolved question lurking beneath all of this. Did these similar bodies arise through the same invisible genetic roots? Smithsonian researchers say that remains an important open question. Scientists have found molecular similarities in some marine species, but whether the same visible anatomy always comes from the same genetic pathways is still being investigated. Even after recognizing the pattern, science is still asking how deep the repetition goes. Is evolution replaying the same solution from different code? Or are there hidden biological pathways that keep getting reused? Are these predators echoes or reruns? And maybe that is why this mystery is so hard to shake. Because it doesn't just change how we see sharks, dolphins, ichthyosaurs, or mosasaurs. It changes how we see evolution itself. We are taught to imagine life as limitless creativity. And it is, but the ocean reminds us that creativity operates inside reality. Inside currents, inside drag, inside prey behavior, inside extinction, inside the simple fact that some designs move through water better than others. So when the sea demands a hunter, evolution experiments. Then the experiments begin collapsing, not into one species, into one idea. The same predator is not a fluke. It is a verdict. A verdict delivered by water, speed, and time. And that may be the most cinematic truth of all. Across hundreds of millions of years, after mass extinctions, after lineages rose and vanished, after land animals returned to the sea and were stripped down by selection, nature kept arriving at a familiar shape in the blue, not because it was copying the past, because the hunt was always waiting. Somewhere right now, beneath the surface, modern bodies are still living out an ancient equation: fast prey, open water, relentless pursuit. And every time that equation appears, evolution leans toward the same answer. Which means the real mystery was never, why does this animal look like that? It was, how powerful must a set of natural rules be? If they can make fish, reptiles, and mammals all start to resemble one another, that is not just adaptation. That is convergence with teeth. And it leaves us with a final, unnerving thought. If Earth's oceans can keep summoning the same predator from entirely different branches of life, then maybe the natural world is not as open-ended as it feels. Maybe some forms are so effective that, given enough time, life is pulled toward them again and again, like iron toward a magnet. A shark is not just a shark. A dolphin is not just a dolphin. An ichthyosaur was never just an extinct reptile. They are separate answers to the same ancient question. And somewhere in that repetition is a warning and a wonder. Nature is stranger than our categories, more constrained than our imagination, and more inventive than either of those truths should allow. The ocean did not create one perfect killer. It created the conditions that keep calling it back.